Hi and welcome back to my channel. Thanks for joining another video. Today's victim of torture testing is an amplifier made by Magnat, I guess in the mid-90s, and the model number is the Classic 240. So I had to repair the amplifier. There was something wrong with the power supply section. I changed all power supply transistors and then the amplifier was running. We have a switch for bridged mode or normal stereo mode. We have a subwoofer filter to 50 Hz or to 80 Hz. Or you can set the switch to full frequency spectrum. Here you have the gain knob where you can adjust your input sensitivity. There are the RCA inputs and the power LED indicator. So you have your speaker connections and power connections and the high level input connections. Let's see what this amplifier can do on the dyno. The Magnat Classic 240 is connected to the dummy load, and I start as always with a 1 kHz continuous power test. I have connected a 8 ohm mono load to the amplifier. That means I'm testing 4 ohms per channel, both channels driven. Oops, clipping. Now we are at 50.4 volts. The amplifier delivers 81.4 watts of continuous power into a 4 ohm load per channel, both channels driven. Let's see how many amps the amplifier pulls out of my power supply. That's 19.1 amps. The amplifier's efficiency is around 62%. Continuous power test with 50 Hz. Oops. I reduce the input signal because it looks a little bit dirty. This is what we can take. We have 48 volts. The amplifier delivers 73.8 watts of continuous power with 50 Hz into a 4 ohm load per channel, both channels driven. Dynamic power test with 8 cycles first. And with 8 cycles I have a peak voltage of 50 volts. That's also around 80 watts, so we have no dynamic headroom. I switch to 20 cycles. There we have our cycles. I go to the last one, of course, to check if the last one is clipped or not. There it is. And we also have output power of output voltage is around 50 volts, so we don't have dynamic headroom. We have also around 80 watts. I'm going to check if the amplifier can put out some output power with just one cycle. It's going to look bad. At the bottom I reduce. We can take this one and we have an output voltage of 54 volts. For just 1 millisecond the amplifier delivers 93.4 watts. So we have 4 ohms mono connected to the amplifier. That means I test 2 ohms per channel, both channels driven of course. I start with 1 kHz continuous power. Oops. And I have a peak voltage of around 42.8 volts. The amplifier delivers 117.4 watts into a 2 ohm load per channel, both channels driven. That means we have around 234 watts. Bridged mono 4 ohms. That's not bad. I'm surprised. And let's have a look at the amplifier's efficiency. It pulls 32 amps. If the amplifier is tested with 2 ohms per channel, the efficiency goes down to 53.7%. Continuous power test with 50 Hz, 2 ohms per channel. Oops. The output voltage is around 40.8 volts. The amplifier delivers 106.7 watts into a 2 ohm load per channel, both channels driven, if tested with 50 Hz. Dynamic power test into a 2 ohm load, 20 cycles, 1 kHz. On the last cycles we have a voltage of 42.8 volts on the first. Also 42.8 volts. That means we don't have dynamic headroom. I'm going to test with 8 milliseconds. I check one of the last cycles and we get a slightly higher voltage. We have 43.2 volts. We have a higher voltage, but the negative waveform starts to clip. So I will say we have no dynamic headroom with 8 milliseconds. And now I'm going to check the output power with just one cycle, and then I expect higher output voltage. Let's take this one. Some distortion is there. We have 50 volts. For just 1 millisecond, the amplifier delivers 160.3 watts into a 2-ohm load per channel, both channels driven. My personal conclusion about this amplifier is way better than the Magnat Classic 360 I tested, I think about 1 year ago.
Thanks for watching. See you next time. Bye bye.